Good afternoon. My name is Serge Desjardins. I'm going to be the convener of this session, Multidisciplinary Community Service and Education. Sure. So it's going to be an interesting session because we have to decide what we want. The first speaker is Doris. She's a director. And then at the beginning, she had 15 minutes. But it was already a small session. So I contact Doris and say, would you mind to extend a little bit further? So she said, yes. So 30 minutes. And then suddenly we got a withdrawal at 2 o'clock. So that's why the schedule is from 1:30 to 2:15 before the next speaker, which will be Aston. So that means basically the withdrawal give us a 15-minute gap. What do we want to do with this 15-minute gap? Doris doesn't have necessarily 45, but we have a director with us. So I think it would be interesting that we go with like a discussion. So I don't know necessarily how we can do that. Is there some people who could support Doris in the discussion? So think about this, okay? I'm not asking the solution now, but for sure we can certainly take our time and then please ask questions. So we're gonna have we're gonna be able to fill this time, okay? So some rule. These are 15-minute presentation, including the Q&A. So I'll show you 5 minutes when there's 5 minutes left, and then someone prepared that, so we're gonna use it. So if you see this 3 minutes, these are the people who present. If you see the 3 minutes, that means basically if you continue, you actually in your period of question and answer. So that's your decision if you don't want to have question and get answer. Then the 1 minute, it's like there's 1 minute left, and then don't try to go there. Okay, 0 minute. Yeah. Yeah, for those who, I don't know if there's some people that actually attend the Congress. At some point, I was convener of a session. I had my guitar, and then I was actually doing like a major chord for the 3 minutes, and then when there was less, it was a minor chord. But I didn't have room actually to bring my guitar, so we're gonna go with that. Okay. So let's start. So the first speaker is Doris, and then please welcome Doris.
Merci beaucoup, Serge. Vous m'entendez? C'est bon? OK, parfait. Alors, merci pour l'introduction. And I'm going to try to fill some time here, but I really would prefer having a conversation. So maybe I'll start by saying that I'm here to present an update on the Meteorological Service of Canada and some of the work that we do in this organization. I have many colleagues here that I will ask questions of if needed. So please ask hard questions so I can try to rely on them. That would be great. So the MSC, of course, is the Government of Canada's institution that provides weather forecasts for everyone in Canada. And maybe the other thing I'm going to say, just because I know there's like some people in training here, like students and postdocs, I have a science background and I kind of moved to the dark side of policy. So, I'm actually happy to talk about that as well. So it's really nice to see some familiar faces, people that I haven't seen in years because they retired and are still enjoying the world of weather. And Charles is walking out as I'm saying this. So I'm gonna, yes, he will. So I'm gonna, great. So I only have, I think, 5 slides. So imagine like how I felt when Serge said, oh, you have 30 minutes now instead of 15, and now I have 45 minutes. So I'm going to be talking quite a bit here. So for some of you, you probably have seen a slide like this already at this conference I have at the public lecture earlier today. And really, it's like the observation that over the last 2 decades, we've had an incredible number and variety of extreme weather events, and these have been quite costly for Canadians and the Canadian economy. So in general, I think in the past decade, insured losses due to extreme events have totaled an estimated of over $30 billion. And the most recent decade accounts for 68% of that damage. So that speaks to 2 things, right? The increased frequency and intensity of these weather events, but also the increased sort of built infrastructure that we have and the aging infrastructure that we have, right? So that's why those costs are increasing. So as we look back to 2024, it's striking to see even how many successive and at the same time events we've had. So just recall that last summer, in a matter of 3 weeks, we had the Jasper wildfires, a big hailstorm in Calgary, as well as the remnants of Hurricane Debbie, which caused quite a bit of damages. So just last year, the cost in insured losses for extreme weather event was about $9 billion, and 80% of that financial figure was from these 3 events. But there were many more events, and I really want to speak a little bit about those. So one that really struck me was a multi-day heat wave in Canada's north. So the temperature was above 30 degrees for several days in a row in Inuvik in early August. Obviously, highest recorded temperature ever in that town, right? And we also had sporadic heavy rain, which caused quite a bit of flooding in urban areas, including in Toronto and Montreal. So if I go back to that close to $9 billion insured loss last year, and you think about these other events, you know, we can all tell that the cost of extreme weather events is not limited to insured losses, right? So there's other losses, including damages to public infrastructure, negative health impacts, loss of life, reduced life expectancies because of negative health issues. There's massive changes in our natural capital, so forestry and all the natural environment, and many effects on Indigenous and other cultural traditions, as well as ecosystem collapse. And we know that these events will continue to happen with an increasing frequency, because even if we manage to actually stop or slow down emission or decrease them, as we've committed to do in past years, the warming is still continuing for a while, right? So we're going to see these events for quite some time. And the piece that I think we haven't quite grappled with, and that's something that I want to leave all of you to think about, is the fact that as events become more frequent and repetitive, you're having compounding impacts on people, communities, and the built environment. So I think we still think of events as singular things, but I think we're going to see more and more the compounding effects of events in time and in space. Okay, I hope that was enough time on one slide. So the little bit of intro here on the Meteorological Service of Canada. I've already said a few things about it. So it's part of the Government of Canada, and it's in Environment and Climate Change Canada. And basically the role of the MSC is to serve Canadians, Canadian institutions, including all levels of government, and many other specialized clients and users of weather information, with weather information, data, forecasts, and other types of environmental prediction services. So the work of the Meteorological Service of Canada, of course, relies on scientific research, and we have some of that within the department. But we also do quite a bit of collaborations with academia. So that's my kind of little intro for those of you who are not familiar with the organization. And the MSC is organized like your prototypical kind of weather service, and that you see across the globe, right? In Canada, the service includes monitoring conditions across Canada from coast to coast to coast, and I'll come back to that in a little bit. The data we collect and other data is sort of ingested in models, and those models predict future conditions. And then we have very, very bright meteorologists who then take all sorts of information and give you great forecasts and give great forecasts to their clients. So our monitoring networks, we have several of them, and they collect about 1 million observations daily. And we take those and we combine them with 12 million observations that we get through data exchange via the World Meteorological Organization. So one of the things when I came into the world of weather is that I was amazed at the volume of data and how much stuff was moving in and out every day, basically. And there's many more observations that we don't currently use or rely on. And then we produce forecasts, obviously, and that means that we produce a lot of information on a daily basis. And so, just to give you a figure, like there's about 4.5 terabytes of data that's downloaded by different users every day. So that's like what we give Canadians, but there's also super users, third party that then take that information and sort of provide it in different ways or provide value add kind of products. So when it comes to the MSC and what we provide directly, right, we provide tens of thousands or hundreds of thousands forecasts every year, different kinds of things, forecasts for the public, forecasts that support aviation, air quality health index forecasts, marine, ice, and sea state forecasts, as well as extreme weather warnings. So sometimes, maybe not in this this crowd here, but my family will think that the weather is like, it's 3 degrees and it's sunny. This is meant to say it's much, much more than that, right? And in Canada, actually, our website, which is weather.gc.ca, is accessed by 90% of the Canadian population every day. So I'm told that it's a website that's more popular than the CRA and any other Canadian website. So Canadians sort of, and we're all Canadian, many of us are Canadian here, if not all, we love to talk about our weather. So people really access that information in many different ways on a daily basis. You can stop me if you have questions. We have lots of time if you want me to repeat that. So I said it was an update. So I think there's a few things I'd like to share with folks. So this is a bit of a 2024 year in review, a bit of a snapshot. So one of the first things that I wanted to mention is that in 2024, we completed the Canadian Weather Radar Replacement Project. My crow is sitting over there, and I'm pretty sure my crow was one of the architect of actually getting funding to be able to replace that radar network. Mike was my predecessor's predecessor, maybe. So you can see how these projects are really, really long in coming, very complex. But this year we actually completed that. So it was a 10-year kind of major infrastructure project where the MSC renewed the entirety of the radar network. And we obviously upgraded these networks to new technology. So we now have 33 radars in total. 32 are operational, and there's 1 training radar located in Ontario at a place called the Centre for Atmospheric Research Experiments, which is a test site where we test a bunch of things. So our radars are a key element for forecasting short-term severe weather, including thunderstorm, tornadoes, hail, extreme rain, and ice events. And our new radars have dual polarization technology, I don't know what that means, which helps our meteorologists, of course, better detect and predict severe weather events, including tornadoes at an extended range, and issue severe weather warnings. The radar also help us distinguish between different types of precipitation, which is also very important. So with this extended range and the fact that we can see things earlier with these better radar, we can give Canadians more lead time to take shelter when they need to. The radar now cover much more of the geography of Canada than the previous generation of radar. So again, we're able to inform more people or inform about a bigger geography in terms of what the weather is going to look like. So of course, we don't just put new radars in place. I wanted to say that since those radars have been installed and sort of in parallel to this radar infrastructure project, we've also significantly improved some products that we provide to Canadians using the weather radar. So I wanted to mention specifically the National Weather Radar Composite, which now includes enhanced precipitation, and that's available on all of our public platforms. So we're upgrading the technology and the instrumentation that we use that serves our forecasters, of course, but we also try to provide products that are better at answering the needs of Canadians on all of our dissemination platform. Next, I'm going to move on to artificial intelligence, and I'm happy to discuss that. So since mid-2023, the MSC has been advancing at a fairly accelerated pace in terms of defining how we're going to use AI, how we're going to integrate it in our models, and sort of experiment with different systems to see like how we can have better services by integrating them. So we now have actually some AI machine learning models that are running in what we call experimental modes in the MSC. We've been testing both of our own as well as private sector AI models that are made available through open sources, just to see how they behave, how they perform. And this is a new thing for us. I think we've taken an approach very much in the past where we would look at things that are generated internally, and now we're kind of testing like other countries and other centers model. We've started with AI in numerical weather and environmental prediction. That was kind of I don't want to call it a low-hanging fruit because it makes it sound too simple. But AI and machine learning, of course, it's an opportunity for across the services, right? So you might imagine that you could use AI and machine learning to do quality control on your data, on your observations, to fill gaps in what you have, use it in the service area. We've started very much in numerical weather prediction systems, but it's going to grow quite quickly because the world of AI and machine learning is moving really, really fast. So at ECCC specifically, our research and development teams have developed a hybrid system. So that's a system that combines both AI and machine learning aspects with a traditional numerical weather prediction model. And we're using that to do 10-day forecasts. And basically by doing this hybrid approach, we're seeing improvements in model performance that would have taken us years to implement in terms of how we normally do innovation in our traditional models. So just bringing in AI is also enabling us to accelerate how quickly we can improve things and change things. So our hybrid model has been running since March 2025 in experimental mode again, so that's very fairly new. And we also published an AI integration roadmap for numerical weather and environmental prediction that's available publicly. It's the kind of document that becomes obsolete almost as soon as you publish it because the world is changing so quickly around us, but I wanted to point it out. In 2024, we also completed, again, maybe another thing that Mike Crow, who's left, I'm going to blame him for that, initiated when he was in the service. We completed a big transformation initiative for the National Hydrological Service. So in the Meteorological Service of Canada, we actually have a service that measures water levels and flow. That's called the National Hydrological Service. Some people sometimes don't know that that's the case. That is within the organization. There's obviously lots of linkages between water in rivers and water in the atmosphere and weather. So it makes sense to have it together. But basically, we completed some big investments in the National Hydrological Services last year. And amongst other things, we did some significant upgrade of aging hydrometric infrastructure. We also developed a new capability, a hydrological modeling capability, and using tools and expertise that are the same as what we use for weather prediction. And as part of that transformation initiative, we also tested and sort of implemented a lot of different innovations. So for example, we're now using like surface velocity radar and image velocimetry to look at stream flow and to look at what's happening in a given river from a distance using camera and things like that. So basically, this transformation initiative helped us like bring up to power some of our infrastructure, but also start pivoting to the future and looking at new technology. And the last piece that I wanted to mention here with that slide is that last year we implemented the Coastal Flooding Prediction and Alerting Program, which is a new program basically that allows us to issue coastal flooding forecasts in many different areas using new modeling techniques, and we use a coastal flood risk index. So this is another great example of work that's been ongoing for several years, where we really started with the science and then developing new services and new products for Canadians. So the Coastal Flood Risk Index evaluates the likelihood and expected impact of an event to determine the level of risk it poses. And basically, our meteorologists use that to assign an event a risk rating ranging from low to extreme, and that speaks to the impact it's going to have in communities that will be affected by it. And so now, basically, with this capability, we're able to predict and alert for coastal flooding on all of Canada's coast, including the Arctic, as well as the Great Lakes and the St. Lawrence River. Still no question? How am I doing on time? Am I speaking too fast? Do I need to slow down? Remember, I only have 5 slides. Okay, so now I wanted to turn a little bit to the present and the future. And the idea here is that there's a lot of things changing. I've already mentioned the advent of artificial intelligence and machine learning. We've talked about climate change at the beginning. That, of course, is changing what people want from us, how they want it, how quickly they want it. And it's also changing what our staff, our meteorologists have to do, right? So basically, as a result of climate change or more extreme weather event, there is a, Jim, I can send you that later. There's more demands on our services, right? I've already mentioned that we seem to be going from one severe event to the next, and at times there's concurrent events. There were 3 events that I mentioned earlier that happened in a span of 3 weeks. This obviously has a huge impact on our meteorologists and other staff, as well as our warning preparedness meteorologist. A couple years ago, and I can't remember the hurricane name, Fiona, I think it was, the warning preparedness meteorologist in the Atlantic basically lost his voice because he was speaking so much to media about the event, right? So I use that sometimes as an anecdote for when I speak to policy people about what it is that meteorologists do on a daily basis. So Bob Robichaud actually had lost his voice during Hurricane Fiona because he did so many briefings, and there was such a demand for the kind of information that he was providing. So how do we adapt our organization to this, right? We need to think about the state today with the increased weather events, but we also need to think about what that's going to look like in 5 years, say, and we need to start pivoting the organization and start pivoting or thinking about how we're going to address this change in demand because of the change in the climate. So I'm gonna put a plug here on several sessions tomorrow for my colleagues, some of which are all sitting on that table there. They're gonna give some presentations on how we're thinking about changing or transforming our services and some of the products that we provide Canadians, so that we rely a bit more on automation for some routine things, and then where we need their bright mind, we give them the time to do that really important strategic work that they need to do, and that's so useful to both Canadians as well as emergency management organization and other partners. So our services are changing, like I said, demands on our staff as well as demands on different products and different ways of communicating. I think gone are the days of people just wanting to know how many millimeters of rain there's going to be. They really want to know, will my commute be affected? What's going to be the impact on me? Should I start my sump pump? So I think we need to move more and more towards that impact-based kind of space, and the organization is doing that, and I think you're going to hear about that tomorrow as well. Our observation networks and our models. So our observation networks themselves are susceptible or vulnerable to extreme weather events. So in any extreme weather events that we have, I can use wildfire as an example, floodings are other ones. We can lose sensors, we can use installation, Sometimes our sensors actually only work up to 35 degrees, and then if the temperature is above that, it doesn't work. So we even need to like sort of adapt our observation network and make themselves more resilient to our changing climate and significant weather events. We have a significant footprint on the land and at sea with all these observation networks. We need to basically maintain, service, upgrade, and innovate these networks on a daily basis. And now we have the added task of making these networks more resilient to extreme weather events. In addition to that, we have still, as you may not know this, some pretty important gaps in where we actually collect data about conditions in Canada, in particular in less densely populated areas. So if you looked at a map of where we have observation infrastructure everywhere in Canada, it's mostly in the south, very little elsewhere. But these gaps are relevant and basically impact our ability to feed our models and predict conditions at very high resolution. We also know that the Arctic is warming at 3 to 4 times the rate of the global rate. And so it's an area of the world that's changing dramatically and dramatically fast. And this is where we have the least number of observing structure. So we continue also to have some important challenges in our model, so including forecasting precipitation, which I've been told is very difficult. And that precipitation is becoming more frequent, more abundant, and so we need to be better at doing that. So we continuously do research to try to improve these models. And we're doing that at the same time as the world of numerical weather prediction is being upended by the arrival or the emergence of artificial intelligence and machine learning, which I've already mentioned. You've all seen a media article about amazing third-party AI models. I'm just going to give you a little funny anecdote. I walked into a senior management office at the department not too long ago who basically asked me, why do we need models? We have Google Deepcast. I think I told that to Jim already. So we have to combat that a little bit. There's huge potential. The potential is enormous. It's really an exciting time, right? I remember, I'm wondering if it's even like a big pivot the same way that supercomputing was a big pivot for numerical weather prediction many, many years ago. So future will tell us that. But of course, these models don't quite have the richness yet of everything we do with traditional models. We don't have all the variables and the resolution is still coarse. So we need to continue integrating AI, test models, test innovations, but also continue running our traditional models. So we're kind of living in both worlds at the same time. And that can be challenging. So hence its appearance on that little slide. I've already talked a little bit about some of the staff pressure that we have with all these new events and what it means to provide information that's both like important to save life, protect property, and support the economy. We have to like sort of think about how we provide this information. So some of my colleagues, I think, will talk about that, but we use different approaches basically to bring in people when there's a big event or when there's multiple events, and that's difficult for people to manage, right? So demands are rising. There's lots of work, and it's not getting easier for anyone. And of course, our staff also needs to adapt to all the technological changes that I've mentioned. So not an easy task at hand. I think this is my last slide, folks. So just like Canadians and colleagues in the other sectors everywhere, we need to continuously adapt to this changing environment that we're surrounded with and think ourselves about resilience of the organization. So we support the resilience of Canadians, but we also need to support the resilience of the organization. So I wanted to talk briefly here about a few things that we do as part of our policy analysis. So my day job is in policy, it's not in science. But we're doing several things to sort of think about the future of the organization. And so one thing that we've initiated, and that's out there in the world, it's been published, is that we're doing an assessment of the essential functions of a public meteorological service in Canada. And we're using the Council of Canadian Academies to do this independent, peer-reviewed expert paper, thinking about what that future is going to look like. And Jim, who is sitting right here, is the chair of this panel, and we're really looking forward to seeing what the panel is going to come out with in terms of advising us on how to position ourselves for the future. I talked quite a bit about artificial intelligence and machine learning, which opens a lot of new doors. Traditional models are still relevant, but we need to continue bringing in these new tools, and we need to do it in a way as well that works with others who are coming in as new players in the area, right? So how do you work with these new partners that can move faster maybe than we can, and that have like kind of different means at their disposal? So how do you do that while at the same time ensuring that the government of Canada is still the voice for alerts in Canada for severe weather events? As part of the sessions tomorrow, I mentioned I'll be participating in a panel discussion on enhancing collaboration for weather preparedness in Canada. So there's lots of potential for collaboration here, and I've already mentioned that. There's people that are normally in our world, but I think we can be creative and collaborate with new people. And while at the same time thinking about how to do that in a way that Canadians can still rely on accurate information. So the government is interested in really thinking about misinformation and disinformation right now. And certainly the abundance of new players in the field is sort of opening some interesting ideas and questions with respect to challenges to that, right? So who do you listen to in terms of taking shelter when there's a severe weather event coming your way? We need to be better at collaborating across disciplines. I think I made the point, right, that there's the weather, but there's the impact, right? So we need to start from the physics, the math, and then move to social science and everything in between, basically, and all work together to give better outcomes to Canadians as well as other institutions. So tomorrow, I've mentioned that a few times, quite a bit on transformation of service. Invite everyone to join us. And you'll get a glimpse a little bit as to what we're considering for the future. And then I hope that with this last slide here, I've also given you a few avenues of things that are interesting to us and things that are keeping me up at night a little bit, but also really exciting in terms of thinking about what the future holds for all of us. So I'm going to stop here. I don't know how I'm doing on time.
I think all people will join the session tomorrow because tomorrow is going to have less session in parallel. Okay. So we're going to converge into a session, and I'm sure this session about transformation would be quite popular. So a hint, if you want a place, probably you should come up earlier. So we have about 15-ish minutes for question, for sure. There is a question, but then we can extend further if some people actually wants to say something.
There's a question in the back.
Hi, thanks for that presentation. I'm from a not your field. From the Canadian Geodetic Survey, we provide services the way that you provide services, and so it was very interesting to hear your perspective on the kinds of challenges that I think we're all facing. I wanted to note that and I'm not sure I'm going to make it to your session tomorrow. We have a network of GPS stations receiving atmospheric data continuously, including zenith wet delay and information of that sort, which some agencies are using for their meteorological forecasts. We can do things like atmospheric river modeling using that information and other things like that. There's also you can use those stations to do GNSS reflectometry, which gives you soil depth, soil moisture, snow depth, things like that. We've had some conversations with your Met service over the last couple of years about a GPS Met program. Is there thoughts of moving forward with that, or where's that in your partnership / project process?
I have never heard about it, so I'm interested to talk again and just learn about it some more. I know in general we try to leverage as much as possible, like available data and information out there. We have a process for that. Some of my colleagues, but I don't think they're here, sort of work on this, like bringing collaborative monitoring data in and ingesting it in our products and in our models. So certainly we can revisit, we can just follow up on where we are. But one of the preoccupation, and I mentioned it during my presentation, is where we have gaps, right? Where we're not observing. And some of these gaps are probably more important than others. Like, if you fill the gap, it will have a bigger impact. So it'd be interesting to see how the different areas, like where you are and where it overlays with where we are, right?
Excellent.
And does it fill gaps? So,
Thanks very much.
yeah, thank you.
Okay, there is one online.
Online.
Okay.
You have to do your jogging.
I know we're talking about them.
Yeah.
There's a question from Asan in the chat. So thank you for your excellent presentation. He wants to ask if there are any available meteorological data such as temperature, wind speed, and wind direction, specifically in regions with complex topography such as inlets. And he has another question. Is there a long-term archive of long-term cruise data or radar data available for these locations?
What's the first data you said?
Meteorological data such as temperature, wind speed, and wind direction. He's talking about specifically in regions with complex topography such as inlets.
Possibly. We'd have to share the maps of where we're measuring. But then you asked a second question about long-term data.
Long-term cruise data.
We have a climate archive that spans like decades, if not a century. So we'd have to see if that meets the need as well. I believe there's an email where people can ask questions about our data, but I would need, this person can contact me if they want, and I can try to connect them with the right person.
Well, I'm bringing the mic. Do we have students here? Raise your hand.
No students.
No student?
One student over
One
there.
student?
Two.
Don't be shy to ask questions about MSC, Meteorological Service of Canada.
That's right.
Hi, great presentation. So my question, I guess, about the gaps that you mentioned, and possibly it's also for the other department. I know there is high or increasing interest from government departments in the Arctic and for different types of operations. So how bad is the current situation? Like, are there completely blank areas or like some high degree of uncertainty in the observations, and how it impacts the weather forecast, the nowcasting, and the like longer forecast? And also with this new, I saw that a significant portion of your operation is airborne operation forecasting. So with the increasing, use of these new platforms, UAVs and personal mobility, there are a lot of talks about the importance of the density in urban areas of this microclimate measurements and gusts and stuff like that impact this mobility. So what's the plan for the future, I guess, in terms of investment in weather forecast? Sorry for the long question.
No, it's a great question. So there are definitely some gaps in observation. I wouldn't say that there's a blank slate anywhere, but there's a higher density of observation in the south where there's more people, as I've mentioned, and less in the north. There's challenges with doing observations in the north, right? It's remote, it costs more money, it's difficult, the terrain is changing, right? So we had, and we're not the only ones, with the permafrost melting, like does it still make sense to put infrastructure on the ground? how else can you measure? So there's lots of challenges with that, and we've met them. I don't think I can answer like specific to your questions. I think I'd have to refer to like people who actually know what they're talking about, as opposed to me, who's a policy person. But as part of my role, I do participate in the World Meteorological Organization, right? And it's a general observation that around the world there are some significant gaps in observation, and the WMO, basically to respond to that, created some standards in terms of spatial density and frequency of measurement that people should do to feed numerical weather prediction models. And the WMO is sort of moving to try to fill some of these gaps. So Canada, especially in the north, we don't meet those spatial resolutions, right? So it has an impact. The Canadian models are quite good, and we've put quite a bit of emphasis on the our Arctic model. But I think having more observations would be useful. In terms of plans for the future, we're kind of looking at everything. Like there's possibilities with satellite-based Earth observation. The department has done quite a bit of work with Natural Resource Canada as well as the Canadian Space Agencies on thinking about the future with respect to that. And then looking at sort of alternative ways of doing observations, as you've mentioned, drones or UAVs and things like that. I can't really share concrete examples, like nothing is kind of being implemented. Some things are being thought about, some things are being tested. Yeah.
Okay. Do we have someone online?
That was the only question.
Okay. So one last question.
The illustrious Jim Abraham is going to ask me a question.
You've done it's very impressive presentation, Doris. I won't say anyways, I do have a question.
Great.
So what's happening south of the border is really tragic. The question's not going to be as hard as you think,
Okay.
but, and it's really, I get asked by the media, because I'm allowed to speak, about the impact on science and on our own weather business, which is obviously, a challenge. It doesn't help anybody. The American Meteorological Society is doing a lot of work, politically and otherwise, rallying as many Americans and internationally on the importance of the weather enterprise. In fact, the weather service, the government weather service in the States and NOAA in general. Do you have anything you can think of while we're here at a CMOS Congress, what CMOS could do, not that that's going to happen, but anything CMOS could do and we can talk more about this at the panel tomorrow, but thinking about things we can do together. This meeting is one thing, but other things CMOS can do. If that ever happened, of course, we'd have to step up, but is there something that comes to mind that CMOS could do for the weather service?
So one of the things that we're starting to think about is where, so in the WMO, and you know this, Jim, right, we're organized from a regional perspective. So in our region, there's Canada, the US, Mexico, and Caribbean and Latin American countries. And my understanding is that the US is providing quite a bit of support on many different fronts to those countries. They're continuing that support right now. But I think we need to start thinking about what would it look like if they step back, say. What would that mean for those countries, but also potentially for Canada and others to potentially step in, as you said. So we're just starting to do that work. I think right now, we've had no formal communication from the US, right? That they're stopping, some collaboration that they have with us, right? It's important to say that. We're thinking about where we have dependencies and where we're maybe vulnerable or not, but nothing has changed formally as of yet. But that work is important, and I think that our our first round of thinking about this was very much internally focused, right? What would be the impact on us? Because our first duty is to provide weather forecasting services in Canada. But like I said, that second order question then for our region or for the more global kind of weather enterprise is kind of next, right? So it's an important question. I don't have an answer, unfortunately. We have an executive council meeting of the WMO coming up. I'm sure it's going to come up there. Yeah. But yes, CMOS, it's AMS has stepped in some places, right, to maintain database, to send scientists, I think, or support scientists. So it's really interesting what they've been able to do there. So thinking about what CMOS can do is also a really great question.
Okay. Merci beaucoup, Doris.
J'ai rempli le temps?
Yeah.
Awesome.
Thank you very
everyone.
much. Next speaker is Aston Chipanshi.
Thank you very much. I hope I also have 30 minutes. Anyway, my name is Aston, as has been announced, and I'm making a presentation on behalf of 3 departments. I represent Agriculture and Agri-Food Canada. My co-authors are from Natural Resources Canada, specifically the Canadian Centre for Remote Sensing, and Statistics Canada. And my topic is, I guess, on updates on the use of the VIIRS-derived Normalized Difference Vegetation Index in crop yield forecasting across Canada. Here is a little bit of background or why we are doing this work. Some of you may know that we produce crop forecasts ahead of harvest. We produced the first forecast around July. So by July, we know in advance how much we can expect across Canada. And we do that with the help of a lot of data. But the key data that we use is NDVI, the Normalized Difference Vegetation Index, which comes from the MODIS platform. Unfortunately, this platform has been around for a lot of years, and it's about to be retired. So we thought of finding an alternative. And the alternative that we are looking for is VIIRS. And so we wanted to see whether this replacement is really real, for real, or whether it's just something that we shouldn't rely on and find something else. And so in this talk, what I'm going to do is essentially to present to you this alternative index, and at the same time try to maybe share some results of our initial validation testing of this index. And so the objectives of this talk is threefold. First, we just want to compare the, I guess, the baseline index with the new index and see whether it's doing the job that we want it to do. And like I said, we are going to use 2024 as the validation period. We also want to look at some, I guess, skill levels. We want to see whether there's any skill in the new index. And we want to see whether we can go forward with this index in future, starting with this year. A few details about the technical details of NDVI, and I should confess the experts on these are the Canadian Centre for Remote Sensing. So if you want more details, I'll give you the email addresses at the end. But we know the source of the baseline index, the MODIS, the one I talked about, it's got a resolution of 250 meters. And it's actually processed by our group. Statistics Canada does some quality control as well. The new index, like I said, is actually processed by CCRS. They get it from NASA and NOAA, and with the problems that were mentioned in passing, we don't know if this is going to be available or not. But anyway, for now, that's our source. There are a number of corrections that are done, and there are 3 quality control measures. One is the AQCS, which is all quality clear sky. And then the next one is best quality clear sky. And lastly, we have the blended index. Basically, the blended index is essentially replacing one quality over the other if the pixels are not there. And I'll show you that in a map form in the next slide. So this is the map on the top left is the baseline MODIS, NDVI, and this is during the peak period, 2004, around July. That's when we get the maximum index. And then you notice that the bottom left, we have pixels that are missing across Ontario and Quebec. But you notice that on the top right, we have a less quality VIIRS NDVI with pixels. So what we do basically is to replace the bottom left map with the top right map to get the bottom right map. And that's what we call the blended index. So it gives us something to work with. And this is critical because that's when we have the maximum coverage in terms of leaf area development. And that's very important in terms of crop yield prediction. This is how the indices that we are trying to replace look like in comparison to the MODIS NDVI, which is in blue. And we are comparing this between 2 regions, the prairies on the left and Eastern Canada on the right. You notice that the blue and the red are more or less on top of each other. And that's very good. The blue is the blended index. That's what we want. However, we also notice that other quality indices, particularly on the prairies, they are sort of higher at the beginning of the season and a little bit higher at the end of the season. The shapes also are different. We think that this has to do with the climates of these 2 regions. On the prairies, I guess we have what we think is probably a typical arid type of climate, and out east is more or less humid climate. So that's what we think why the shapes are different. This is now just a complete summary of all the indices. What we have on the right are the root mean square errors. And we think that the blended index, which is in green, has the least mean square errors. And so it's a best replacement for the index that's likely to disappear. Next, we wanted now to test these with actual prediction. And we have a model that we have built, which actually Statistics Canada now is using. Instead of using surveys that they used to have about 3 surveys or more, they are now using the model that we developed at AFC, and it's a Canadian crop yield forecast. So what we did in this test, the blue essentially is the baseline MODIS, and the orange is the best quality, and the green is the blended index. So we sort of developed the model using climate variables, the whole of 2000 from 2000 to 2003. That's what we built the model with. And then for the testing, we got the different sources of NDVI so that we could see which one is better than the other. And we used the actual yield values that were reported by the end of December for comparison. And in the next slide, I'm going to show you how this looked like. So what we have here are two crops. The top panel is barley, and the bottom panel is spring wheat. And what we are showing here basically is the difference between what was observed and what was predicted using those indices. And the top left, essentially that is the difference between the baseline, which is the MODIS, which is about to be retired, compared to what was observed. And on the right, that is the blended index. And we notice that the color coding, if you just eyeball, they're pretty much the same. So we think that the blending is actually replicating what's about to be retired very well. And the same is true for spring wheat as well. And that was, if I can just go back, this is at car level. A car level is a crop agricultural region, which is the smallest unit at which we do the prediction. And this is the census agricultural region as reported by Statistics Canada. And after doing these predictions, then we aggregate those to the provincial level. And in this slide, we have two crops. The one on the left is corn for grain, and on the right is soybean. You notice again that the green is actually the actual observation, and the other colors are projections or predictions using different qualities of NDVI. And our conclusion is that there's not much difference between NDVI derived from MODIS and those derived from the blended index, as well as the BQCS. This is, again, just a summary, but extending to other crops. And what we see here, again, is essentially a repeat of the last slide. And this is now showing about 5 crops. So we are doing quite well. In summary, we think that we have found a replacement. However, we haven't done a lot of validation going backwards. So we think that probably we need to do a bit more work looking backwards. But we think that we are on the right track here. So thank you very much.
So we have time for a few questions. Okay, we'll go that way.
Thanks for the presentation. So in the last slide, you mentioned the data sets from NASA and NOAA. You know, given the current situation, do you think it's a good plan to rely on the availability of these data sets in the future as an alternative?
Well, it's not a good plan, but we don't have very many options. We have some, well, there are a few options out there. The one we're pursuing is Copernicus. The Europeans have similar index, Sentinel series. So that's an option. But for now, I think we've been told that the systems that NASA and NOAA are running should be there for us. I can't really say what's going to happen tomorrow, knowing fully well that we are dealing with a very fluid situation. So I can't really say.
So while I'm bringing the mic, when do we lose Moses? When are we going to lose it?
Maybe we've got one more season. That's what I've heard. We may have one more season, but the quality of data that's coming out even now is degrading. So it's not, even though it's there, or we may have 1 or 2 more seasons, the quality of MODIS is not that great. We know that.
Okay, thank you very much for a nice presentation. My question is more technical than
political. So given that the best resolution of VIIRS is 375 meter, how do you scale it to 250 meter?
Yeah, I can't answer that question, but yes, it's, well, it's a surface. You can extract anything you want because it's a model, and you can take out anything you want out of what you have modeled. So that's the basic answer I can give you. But if you want more details, the best person to talk to is number 2 in that slide. He will probably give you more information than I'm able to.
The data you showed appeared to be mostly at the macro level, so things that might be used by commodity traders or grain companies. I'm wondering if you've ever tried to look at the data at a much smaller scale, maybe down to the township level or the field level, such that an individual farmer might be able to predict their yields. And if you have, how did that work?
Yes, no. Yes, we have a project where we are actually looking at quarter section levels. However, in terms of the distribution of data, we don't go to the farm level because of privacy reasons. We are not, as a government department, we are not supposed to identify anybody. So we cannot go beyond the census agricultural region. It's just a privacy issue. But it doesn't mean that we cannot make a prediction as farm level if we want to. And we've done it, except that data is suppressed, it's not made public.
In French, a chairperson is called président, so it gives power. So I give myself power to allow a student to actually ask a question.
Thank you so much. In my understanding, your yield forest system is based on the machine learning things, and in my understanding, the European one, they use the process-based crop model to couple in their system to do the forest, to do the crop yield forest. So do you, in your future work, you want to incorporate a process-based model into your system, or you still want to use the machine learning things? Thank you.
Yes, actually, I have 2 students who are working with me. They are testing a bunch of machine learning modules, XBoost, random forests, and many others. And they're actually using process-based approaches, machine learning modules as well, to more or less like what the Europeans are doing. And we haven't implemented those. They are in research mode. And with time, yes, we might implement those in future. But we definitely have a project on which a number of students are involved right now. So yes, it's on the books.
Thank you, Aston. Now I'm asking Leonid, sorry.
Hello, everyone. Thanks for coming. So this is going to be not a very scientific presentation, more of a practical presentation of a new focus area, mainly to increase the engagement between NRC and universities. But now I'm realizing that it should also include other government departments and not just limited to universities. So a brief reminder, the NRC is the largest federal organization for research. We have 12 research centers across Canada. So today I'm going to talk specifically about the Aerospace Research Center, which is located in Ottawa. And inside this research center, we have 5 laboratories, for different types of aerial related research. So we have propulsion, aerospace materials manufacturing, flight research, and aerodynamics. So as an example, in the flight research laboratory, we have 3 components which have value: the scientists, the brain power, and the different airborne platforms. You can see the helicopters, fixed-wing aircraft, UAVs, and the instruments, the state-of-the-art instruments. Some of them integrated on the aircraft, some of them are separate. We have in situ remote sensing instruments. And if you want to know more about the details, the specifications of the different instruments, one example would be our working horse, the Convenor aircraft, which is equipped with tens of instruments, and this will be in Natalia's talk tomorrow at 11. But yeah, the focus of this talk is about new enlightenment that our management had with decades of environmental research. We decided that we need to increase the accessibility of universities to the facilities that we have, and also given the government, orientations toward this climate research in the recent years. So this new focus area is supposed to enable or benefit your research using our resources and to benefit Canadians. And our activities align with the government guidance, and there's different documents that you can see here. The Government of Canada 2030 emission reduction plan, the Pan-Canadian framework of clean growth and climate change, and other documents. And then you can access the website to read more about our goals. So the environmental focus area, environmental science focus area, has 4 pillars. The atmospheric sciences pillar, Earth surface sciences and observation, modeling and methodology, and sensor development and validations. So the atmospheric science is partially what I was working on. It includes fundamental atmospheric processes, measurement of the composition, extreme weather, air quality, and climate research using our airborne platforms. The surface of Earth surface sciences includes the measurement of the Earth, the topology, or wildfires, trees, canopies, and stuff like this, like biodiversity, using airborne platforms and satellites. And modeling and methodology is about the combination. We're dealing with large data sets, meaning fusion of different platforms and different sensors, a lot of machine learning, image analysis, classification, so all the software development, so all these kind of activities fall under this pillar. And the last one, sensor development, so physical sensor development, including starting from small semiconductor sensor up to like large instruments and satellite prototypes for deployment later on satellites. So why the universities or other government departments should care? Our facilities are world-class facilities. There are a handful of such facilities around the world. We're one of them. We also have the expertise inside these labs, and our presence can actually leverage the success rate of your proposals. We have a unique instrumentation already installed and approved for flying, so you don't need to care about all the paperwork and stuff like that. Although there's a lot of paperwork to the government anyways, but yeah, it reduces your paperwork. Yeah, and publications, if you want to disseminate your research, it gives you more opportunities to publish. And for NRC, it's about training the next generation of scientists, and also the outreach, the dissemination of findings, and improving, the quality of lives and well-being of Canadians, and publications. So there are two main streams, generally speaking, to submit projects under this focus area. One is more sciencey, the other is more like a service. And the main difference is the level of involvement of NRC scientists and the level of support you can get from NRC in terms of funding. Yeah, so this is like a summary and illustration of how it works. Usually, the researcher, the lead scientist, will get some funding from a funding agency. I listed a couple of them here, but there could be others. And as you know, Canada recently became an associate country with the European Committee. So it's now eligible to submit proposals for funding. So potentially this could include, you could include NRC as part of your proposal. And once you get the funding, the PI, can decide, to put some funding into human resources, equipment, or and the Airborne platform. I'm talking, again, I'm focusing about Airborne research. So yeah, now with including NRC in your proposal kind of leverages your resources, and you need to spend less money on your equipment that you planned. You have a broader selection of airborne platforms that you can use. You have additional flight hours. So potentially, if you had 10 hours, you'll have some percentage more, and flight hours are expensive. Yeah, the instruments that I mentioned before, the state-of-the-art instruments, we have remote sensing radars, LiDARs, dual polarization, some experimental equipment, and of course, publications. You're increasing the amount of publications coming out from your research with NRC's scientists. And the training of your students in a unique environment, giving them experience that they can't get anywhere else. So some examples of such projects. This focus area started a year ago. We already have several projects running, and some of them you already heard about in yesterday and today's presentations. So the VIIRS and the ECALOT, mainly funded by the European Space Agency and leveraged with NRC resources to get more flight hours, more labor, more publications using NRC. Some more smaller examples. So this is a project monitoring the efficiency of suppression of wildfires, basically deploying a helicopter to monitor the suppression using remote sensing, IR imagery. And another example of a project with McGill University, I believe the funding coming through Environment and Climate Change Canada, and we are contributing, again, our expertise and some of the equipment and additional flight hours to expand this project and get more information in this specific case about greenhouse gas emissions in Montreal area using different platforms. So we provided the drone and the Twin Otter aircraft. Yeah, another example, monitoring Canadian biodiversity and ecosystem using drone platforms with a hyperspectral camera, developing the methodology. So again, part of it is covered by NRC. Yeah, so this is a summary. If you have any projects that you'd like to leverage NRC's capabilities to make it bigger, have more impact, such as sensor development, remote sensing, or collaboration with European colleagues, so measuring, doing research on large scales between continents and air masses transport or aerosol transport. As well, we have a new weather station established in Ottawa, so any research methodology combining weather stations and airborne research, some sort of advanced data analysis could also be a project. And there was a presentation about the new facility. We recently got funding to buy new aircraft. So any activity that would help to benefit the new facility with new capabilities, like data analysis or some new sensing techniques, can also be part of this focus area and get additional funding from NRC. And I think that's all I have. Thank you.
We have time for a few questions.
Thank you very much for the presentation. In the presentation, you talked about a process that's very researcher-driven, and once the funding is obtained, right, then you sort of tell NRC you have a need for infrastructure or tools or something like that. Do you ever work the process differently? That is engage earlier in the inception or the development of a potential proposal? And I think what's behind my question is really trying to understand if you have any other kind of layers of priorities, for example, under the environmental science. It sounds really interesting, and it sounds like maybe there's areas of common interest there, but I wonder if it gets defined a little bit more, if it's entirely researcher-driven. Thank you.
Yeah, so the schematic kind of that I shown is just one example. There are multiple ways to do it. Once we agree on the right way that works for you, we'll be happy to do it. And as an example, we recently got funding for a Horizon project. So this was obviously developed from the early stages of the proposal. And but what I'm saying is, if you didn't include NRC in the beginning, there's still an option to include it later on, or if you have funding for airborne research allocated.
I mentioned yesterday, thanks, Leonid, that was interesting, very interesting. I mentioned yesterday at PICO-F that it's been 25 years since we flew into our first hurricane in Canada, and we used the Convenor 580. And the paper that was published at the time involved myself, Chris, and Mengistu from your group. And that was funded came from funds from, basically from the Search and Rescue New Initiatives Fund. And that was an example where ad hoc program was developed. It wasn't part of a plan. It was basically taking advantage of low-hanging fruit. The question I have is, are you working at all with the Northern Tornadoes Project, who are doing some innovative remote sensing to detect and classify damage from tornadoes and other severe weather using remote sensing?
So do you mean whether the funding is coming from them or
is there a collaboration that exists?
No, there's it's a new initiative, right? Relatively new.
Well,
yeah,
2 or 3 years, I think.
Yeah. And no, we haven't had the chance yet, but definitely I think my colleagues will be interested in if somebody starts it. I mean, we're already overwhelmed to start our own initiatives, but if there is a project coming in, we'll definitely consider something like that. I know there is extreme weather research going on, not necessarily tornadoes, but just Arctic storms and stuff like that. We have remote sensing that you're probably aware of, and some new tools that were developed recently that could be of interest.
Thanks.
Okay, we have to move on to the last presentation. Micro.
Thanks, Serge. Now for something completely different. I'm going to take you to the other side of the globe, to Nepal, and talk about a project that was conceived when a few of us MSc retirees got together and spent 6 weeks volunteering and trekking in Nepal. And being the meteorologists and climatologists we are, we're very aware of things like data gaps in observing networks around the world, and particularly in the cryosphere. And we knew this was an issue in the Himalaya of Nepal. So we were quite taken by the number of monasteries we ran into when we were walking around the Himalaya. And we thought, why aren't there weather stations at monasteries? So Jamie Smith and I came home and we're thinking, well, there's a good project there. How can we make this work? And Jamie just happened to bump into John Pomeroy at some meeting that he was at, a well-known hydrologist in Canada. And John said, I know a guy. And he put us in touch with Dr. Dhiraj Padananga, who is a professor at the Tribhuvan University in Kathmandu and president of the Small Earth Nepal organization. And they're all very active in Nepal in climate change monitoring and research. And Dhiraj was impressed with the idea, and he said, well, I'm going to bring in a few of my PhD students. So Susa, Dinka, and Binod came along, and as luck would have it, Dinka and Binod are both employees with the Nepal National Meteorological and Hydrological Service. So that gave us a nice connection with the authoritative organization in Nepal. And he thought the other thing we're going to need is money. So Dr. Luna Bharat is a colleague of Dhiraj, who is the head of the research and education at the International Center for Water Resources and Global Change in Bonn, Germany. A very capable individual, very knowledgeable in climate change and impacts, and in particular in funding mechanisms that are available. So we have a nice little international consortium moving forward on this project. I'll just draw your attention to the No, I won't. I'll go to the next slide, if I can. And so what I'll talk about today is a little bit about how climate change is affecting traditional Himalayan lifestyles. We'll talk about the challenges of monitoring in the third pole, as the Himalayan plateau is known, about how monasteries may represent a sustainable solution to monitoring. And then we'll talk a little bit about our next steps. Here, I will just draw your attention to the map in the background to sort of situate you with Nepal. It's a small country. It's bordered on the north by China and Tibet, on other three sides by India. And it's separated a little bit on the east side from Bhutan and Bangladesh. It is a small country. It's roughly 800 kilometers from east to west. Around 200 kilometers north to south, and it has a population of 30 million. It is classified by the UN as a least developed country, and that's a classification that comes from consideration of economic, human health, and education-related indicators, along with a vulnerability index. It's mainly situated on the southern slopes of the Himalayas, but the south lies in the very fertile Indo-Gangetic Plain. which is indicated in the purple shading in the map on the right. And this plain is one of the most densely populated and intensely farmed regions of the world. Nepal's 4 major river basins basically drain into the Ganges, and the Ganges is a major source of water for about 2 billion people. So the third pole really is the water tower for these areas. A little bit about the Nepal economy. I mean, any exact figures on Nepal's economy are kind of hard to come by, but sources like the World Bank, the International Labor Organization, the CIA website, all are in agreement with the kind of figures you see here. Agriculture, while it may not be the biggest contributor to the GDP, it is the largest employer and is the bedrock of Nepal's economy. And we're not talking industrial agriculture here. We're talking about subsistence farming. And it's on fragmented land holdings, poor infrastructure, and it's all very, very vulnerable to climate events. Interesting that tourism and hydropower are growing economic sectors, but for me, the most interesting fact was that 25 to 30% of the GDP comes from money that is sent home by Nepalis who work out of the country, and that's in places like India and the Arabian Gulf states. So it's better. They earn more money when they leave the country than when they stay at home. Climate change in Nepal, there's lots of academic papers and domestic and international agency reports that tell us that climate change is having profound effects on Nepal. Main drivers are the temperature regime and the precipitation pattern changes, and that leading to major glacial melt. The map shows the average snow and ice cover of the Himalayas in 2018, and that had been reduced by about 40% over the previous 30 years. And of course, we have the obligatory before and after pictures. We've all seen these kind of comparisons about what's happening to glaciers, and we've heard about them at this conference, in fact. This particular one retreating at the rate of about 10 meters per year. Consequences of climate change are huge. I mean, the changing climate is basically exacerbating what is already significant issues in Nepal, particularly related to water and food security. Shrinking glaciers and erratic precipitation are threatening drinking water and irrigation supplies, as well as traditional farming and livestock grazing practices. Extreme weather events that are, I should call them extreme climate events, like floods and landslides. These can have devastating effects. When we go for a drive, I'm sure many people in this country, in this room, have gone for a drive in the Rockies in Alberta and BC, and you know that you can drive for miles and the only sign of civilization is the road you're on, unless you count the clear-cut areas, I guess. But it's a very different story in Nepal. When you go through mountain valleys, there's roads that go up all the mountains, and there's farms and there's villages everywhere on the top of the mountains, on the sides of the mountains. So when you have a climate event like a mudslide or a flood, it can just wipe out everything in an instant. Farms, villages, and it's frequently accompanied by loss of life. Infrastructure as well. I mean, what infrastructure there is there in the way of roads is frequently wiped out, and these are the only way people have of moving goods and people around and that kind of thing. And so it can be very devastating. And not to mention that all of this exacerbates what are already major problems in Nepal related to malnutrition and waterborne diseases. And I'll just mention that it's not only in Nepal, but it's in northern India and Bhutan as well, that many of these things are an issue. In addition to the scientific and technical studies, there's a lot of sort of social interactions that have taken place, and Dr. Pradanga has been very active in this area in terms of getting out and talking to the hill and the mountain people about what they perceive in terms of a changing climate. And they invariably hear that people notice this. They know it, and they know it has changed, like in the last 30, 40 years. They notice the changes in the precipitation patterns, particularly the reduction in snowfall and snowpack levels. And people talk about areas that used to be snow-covered now being bare, spring water drying up in the hills and having large effects on traditional agricultural practices. So it's there's an awareness there that this is happening. So in spite of all this happening, monitoring challenges in Nepal are a big issue. I've already mentioned about the gaps in data collection in the high altitude areas. More generally, AWS automated weather stations have a tendency to fail in the harsh conditions, a lot of the time because they're not being properly maintained. Accessibility is an issue. You know, if you get in a car and you want to drive 100 kilometers down the road here in Saskatchewan, it'll take you about an hour. If you want to drive 100 kilometers in Nepal, it's going to take you about 10 hours, just because of the state of the infrastructure and that kind of thing. Vandalism is a big problem. These things are usually run off of solar power, and a solar panel is a very hot commodity in Nepal, and it's the first thing to disappear. And more bureaucratic barriers are coming up as the Nepal government rightly claims areas as protected as park areas, and carrying out operations in these areas can be difficult to move on. Just a couple of maps to illustrate some of those points. You can see in the red outlined area in the north and the high altitude areas, there's very little monitoring going on there. And there's a depiction of the few hydrological or snow measuring sites that are available in the high Himalaya. So monasteries, they're everywhere, and they're a huge part of Nepali life. They act not only as religious centers, but they're community focal points. They're sources of education and traditional knowledge sharing as well. The lamas and the monks are very well-respected spiritual leaders in the community of what is really a very religious people in Nepal. And the people support the monasteries and the religious orders continuously with resources and food, and they're shown a great deal of respect. So there's a number of reasons why we think monasteries could be explored as sustainable monitoring sites. They are often located in remote high altitude areas. They're occupied year-round, and they are relatively secure and relatively accessible. We believe that monks, lamas, and nuns could easily be trained in maintenance of today's modern AWS technology. My voice is going. So we've looked into this already, done a little bit of research as to where there might be some likely sites, and our first pass at it turned up a lot of sites. This map I don't think is by any means complete, so there's certainly the presence there that we need. The funding is a big issue for us, of course, and where we're going to get funding if this gets off the ground. And I think was mentioned earlier, the Global Basic Observing Network of the WMO. The Systematic Observations Financing Facility has been put in place to support the implementation of the GBON, providing long-term financial and technical assistance. And they're prioritizing least developed countries like Nepal, and the GBON is prioritizing cryosphere monitoring. So I've made some initial contact with officials in the soft thing, and they've indicated a willingness to consider a proposal, which is nice. So our next steps, we plan to continue to inventory current monitoring gaps and suitable monastery locations. We'll be further engaging with the religious community, the lamas and the monks, and in particular the hierarchy of the religion, to gauge their interest. And I can tell you, if our first informal engagements with people at these monasteries is any indication, they're very keen. They like the idea of getting involved in this and helping the communities to adapt to climate change. We've got a lot of technical work to do to define the parameters we want to observe, to select an AWS, sighting parameters, all that kind of thing. So we'll be working on that. But our next really big step is to find a location for a pilot project and a proof of concept. SOF has indicated that if you've got that in your proposal, that makes a very compelling proposal. So we want to identify the challenges and work through them, and in particular in terms of the training and that sort of thing. So those are our next steps. In summary, just to say, if I can, as is too often the case with least developed countries, Nepal is one of the smallest contributors to global climate change, but one of the most affected countries. Engaging at the community level to involve the locals in understanding how their climate is changing is critical to helping them adapt to these changes. And since gaps exist in monitoring climate in the high altitudes, an educated year-round presence at monasteries could be leveraged to improve that monitoring and help communities to adapt to climate change. So we're looking for funding, we're looking for input, we're looking for feedback, we're welcome suggestions, and if successful, hopefully we can implement this in Nepal and move on to other countries like Bhutan. Thank you.
Okay, one question from the room and one question if there was one online. Oh, I don't know which one.
You again, you again.
Actually, it's kind of a suggestion, Mike. This is wonderful stuff. I'm part of an American Meteorological Society group on engaging spiritual communities in weather and climate. It's called Cosmos. And there's a fairly decent network across the country that might be of some help in examples of this that could be used in justifying putting together. So I can connect you with them.
Great.
The other thing is actually there is an example like this in Nova Scotia. The Dalhousie Ocean Frontiers Initiative has a fellow who's doing beach coastal zone monitoring and from extreme events. And he's engaged the Anglican Environmental Network, and the parishes along the eastern shore of Nova Scotia are doing citizen science monitoring of the impact in the coastal zone. And no surprise, they all have kokoras gauges. So I'll talk to you more because these are examples that might help with the proposal.
Yeah, for sure.
Okay, since there was none online, one last.
I'm seeing Mike later, so I can also do this very quickly. Mike, as you were talking, I'm reminded of an example that's similar from Colombia. I'm going to have to think more about this, but I remember it was like citizen-based and religious-based monitoring in some sacred areas of the mountains in Colombia. So,
Awesome.
so I'll try to come up because I agree with Jim. I think that could be helpful. I was wondering if there's specific challenges with data transmission in Nepal and from these AWS, and if that's something you're thinking about.
I think there probably is. When I went off on my trek, my wife wouldn't let me go unless I had some way of keeping in contact all the time. And I thought, well, I'm not going to have cell coverage. So I invested about $500 in some satellite phone type thing and took it with me. And I didn't need to, because frankly, there was cell coverage almost everywhere. I was amazed. It was better than Northern Ontario.
That's good.
And just interesting to, be in these little villages where people are farming the way they did 800 years ago. And when the day is over, they're sitting on their porch with their phone.
That's great. Well, thank you very much. That ends the session. Thank you very much for all the speaker, and thank you very much to all of you. And big applause to ourselves. Well, it's a big applause to ourselves. Okay, thank you.